Today we're going to talk about which one changes faster. So here we're going to try and figure out which graph is, or which equation is function. Which equation is graphed for this. Okay, so we have this graph that's given to us. We have a certain viewing window. And the first question we have, which equation do you think the graph represents? Use the graph to support your reasoning. So we could either choose y equals 120 plus 3.7 times x, or y equals 120 times 1.03 to the x power. So if you're looking at this graph, what is your first gut reaction saying? All right, so if we look here, it appears to be linear, okay? So if we do some calculations here, if we plug in 0, that means that our y-intercept would be at 120, which that appears to be. If that's 150, that's 125, so we're shortly below that. If we go all the way over to this other side and plug in 7 for x, we would get 145.9 out. So we're looking at this 7, that's 150, 146. Seems close enough there. Could it be? Yeah, could be. So it appears linear. What about our other equation, 120 times 1.03 to the x power? Well, again, if we plug in 0, we get 120. If we plug in 7, we get 147.6. And that also could be that. Again, we're counting by 25, so it's really hard to see. So could also match the graph. Okay, but here it's really hard to tell. Both of those match up relatively close to this. So then what information might help us decide more easily whether the graph represents a linear or an exponential function? What could we use in this graph to help us? So if we're looking at this graph again, what could help us? So knowing, like, if they put actual coordinates on here, if they actually put the coordinates of these points, we could then see what's happening. Also, it only goes to 7. We have no idea what this question is asking, what this situation is, but it only goes to 7. So if it's 7 months, 7 years, something of that nature, that's not a ton, especially if it's 7 months. So other things that could help us, I would say exact coordinates. Or we would want a larger graphing window. Mainly we would want to increase the domain. For sure. So if we increase this domain over here in the graph, sorry, I'm pointing the graph that you can't even see. If we increase the domain over here, then it would show us what does this do. Does it continue going linearly, or does it become an exponential function? So it just goes to show you that what you're looking at is important. Okay. So our next thing we're going to talk about is reaching 2000. And here are two functions. We're going to let f of x equal 2 times x and g of x equal 1.01 to the x power. Okay, so we're going to complete these tables. So if we take 2 times our x value, that means that we would have 2 there, 20, 100, because 2 times 100 is 200, and then 2 times 500 is 1,000. Okay, so we're going to do the same thing with the g of x function. We're going to take 1.01 to the first and get 1.01, 1.01 to the 10th and get 1.105. Now these are approximated answers to 3 decimal places. So when we plug in 50, we would get 1.645. Plugging in 100, we would get, 2.705. And plugging in 500, we would get 144.773. Again, those are rounded to 3 decimal places. Number 2 here says, based on the table of values, which function do you think grows faster? Explain your reasoning. So if we're looking at this table again, which one appears to grow faster? Well, I'm noticing here, these numbers are getting a lot bigger, a lot faster than these are. So f of x appears to grow faster. But as x increases, g of x grows faster. Okay, this one does increase quite a bit, but this one, not so much, not so much. As we get up here, that's a really big jump. Okay, in this. Now, we are going from 100 to 500, but I would say there would be our answer for that one. Okay, so number 3 says, which function do you think will reach a value of 2,000 first? Show your reasoning, and we can always plug in some more values up here. So I want you to think for a second, which one do you think is going to reach 2,000 first? Remember, the first function we're taking 2 times our x value, and for g of x, we're going to take 1.01 to the x power. So let's take their advice here. Let's fill into the table a little bit with the value of 600. So 600 times 2 would give us 1,200. 1.01 to the 600 power would give us 391.583. So neither one's at 2,000 yet, so let's plug in 700. So then that would give us 1,400 here and 1,059.16. Still neither one, so 800. That would give us 1,600 for the f of x function, and for the g of x function, it would give us 2,864.831. So which function will? G of x will get to 2,000 first. Okay, so somewhere here between 700 and 800, when you plug that in, this one would cross over that 2,000 amount. Okay, let's take a look here about simple and compound interests. So we have this information. A family has $1,000 to invest and is considering 2 options. We can invest it in government bonds that offer 2% simple interest, or investing in a savings account at a bank, which charges a $20 fee to open an account and pays 2% compounded interest. Both options pay interest annually. Okay, so that's important to know that we're annual. And here are 2 tables showing what they would earn in the first couple of years if they do not invest additional amounts or withdraw any money. So here with the bond, the government bond, it's offering 2% simple interest. So what does that mean? So if we look at this, actually our first question does say, how does the investment grow with simple interest? So here, what do you notice? The starting amount is $1,000. And then after 1 year, we have $1,020. And after 2 years, we have $1,040. What's happening here each time? So they're adding 20, okay? And this is simple interest, 2% simple interest, which means they take 2% of this initial amount, which would be $20, and you just add it each year, okay? So this investment would grow linearly because they add $20 each year. Okay. How does for the savings account, how are the amounts $999.60 and $1,019.59 calculated? So if we are looking back, it's a $20 fee. So at 0 years, there's $980 in that account because they've already taken away the $20 fee to open up the account. Then it pays 2%. So if we take that initial amount of $980 and we multiply it by 1.02, again, we had 2% compound interest, that's going to give us our $999.60. Well, then the next year, they would start with that $999.60, and we multiply that by 1.02 because we're getting 2% compounded interest there. And when you do those calculations, you get $1,019.59. So that's where those things are coming from. Okay. Number 3 says, for each option, write an equation to represent the relationship between the amount of money and the number of years of investment. So we're going to have to define that X equals the number of years since investment. And that's probably going to go off the screen for y'all. But since investment is what that says. So for our bond, we start off with $1,000. So we'll say B equals, for bond equals $1,000, and each year they add $20. So $20 times however many years we have. So if we had 3 years, they would just add another $20 to what we had before. Okay. For the savings account, let's call that S. We start off with $980. Remember, they take a $20 out that was our fee to open the account. That's why we're starting with $980. And then every single year we get 2%. So it's going to be 1.02 is our growth factor to the X power. Which investment option should the family choose? Use your equations to calculate or calculations to support your answer. So if you were to actually look at both of these things and continue on your tables, or look at a graph of these two things, they're going to cross roughly after 11 or so years. Okay. So if they cross, which one actually starts higher, the bond or the savings account? So the bond has more money in it initially as you go because it started with $1,000. There was no fee to open that account. So I would say we would want to choose the bond if we're having this less than 11 years. Okay. And it's not exactly 11 years, but it's close enough. So we want to choose the bond. If we're going to put this money and invest it for less than 11 years, it's going to be a better option for us because that's going to be a higher amount. The savings account, we would want to choose that, the savings account, if more than 11 years. So let's actually look at that on a calculator here really quick. Okay. So if we go ahead and we have both of the equations typed in there, if we go ahead and graph these, you're noticing that the top one is the bond, at least the top one over here. It's just going up, it's a straight line. Here the savings account is going to be lower, and then here's that magic point where they meet and cross. Okay, so at this point, that's where you would want to choose the savings account over the bond. 11 years is a lot of money to leave things invested for some people, so they might choose the bond. For other people, they know that they can plug in, or they can put that money into account and let it ride for longer than 11 years, then they're going to want to choose the savings account. Okay? And that's it.